Hello students, myself is Parminder Singh from Prab Kirpa classes. Our today's topic is statistics, meaning, collection and presentation of data. After going through this course, the students will understand that statistics is an important branch of mathematics wherein we arrive at the definite conclusions from the data which is available before us. We will also understand what is the meaning of data and what is the difference between primary data and secondary data. If the original data is collected first hand, it is called primary data. If the information or the data has already been collected by others and it is available for use by the individuals and researchers, that is, if we search any information on the Google or we get any information from the books or magazines, this is secondary data because the information has already been collected by other persons. We have not put our own work on ourselves into collecting the data. The work or the hard work has already been done by some others. This is secondary data. Then the students will also understand that there are various means or ways to collect the data. That is, we can do surveys, experiments, or we can go through books, magazines, or the government records, or we can search the digital records, such as we can make use of search engines to collect the data. Then the students will understand that they can present the data with the help of tables, and the students will also learn that the statistics has various applications in various fields such as business and economics, in the field of marketing, in the field of healthcare. In each and every sphere of life, statistics has its own impact because in each and every business, the decisions have to be taken only on the basis of the statistics. And in each and every organization, say in the healthcare industry or in the manufacturing industry or in maintaining quality control, the decisions have to be taken only on the basis of statistics. If the particular product is not selling much in the marketing, we will have to decide on the basis of the statistics that whether to continue to sell or what steps extra we can take. That is, we can take any decision only on the basis of the hard facts or the numerical figures which are presented before us. In this course, we will understand the presentation of data with the help of tables. We will solve some 4 or 5 examples in this course, and in the next course we will do practical examples of frequency distribution tables. Now the topic before us is introduction to statistics. Now we will understand what is the meaning of statistics, what is the difference between primary data and secondary data, how we can collect data, and how we should present data. Suppose we are watching television, and on the television we are watching news. The news are related to a cricket match between the two countries. How we can know that the particular team has won and the other stands defeated? The news will tell us on the basis of the data that this particular team has scored so many runs in the match, and so it has won. That is on the basis of the runs scored in the match, the particular team is declared won. So it is only the data or the statistics which come into the picture. Now we take another example. We are reading the newspapers. In the newspapers, it is written that the particular political party has won the state elections. How they have won or how they have been declared won, it is only on the basis of the particular number of seats which they have won. That is the again the role of data or the statistics come into play, because the particular organization has won more number of seats as compared to its competitor political party. If we see the any business news channel, the same may be stating that the particular organization is continuously increasing performance. How they can say? They will give the pictorial presentation of the data that the profits of the particular organization are increasing year by year. Here again, the data or the statistics come into the picture. In the same way, we say that the global warming all over the world is on the rise. That is, the temperatures of all the cities across the globe is increasing. How it is derived? Because it is on the basis of the calculations or the data which is collected by the meteorological department or other research organizations. Here again, the data or the statistics come into the play. Now we will learn the same in theory. Every day we come across a lot of information in the form of facts, numerical figures, tables and graphs. We get this information from newspapers, televisions, magazines and other sources of communication. The information which we get from newspapers, televisions, magazines or other sources of communication may relate to cricket batting, bowling averages, profits of the company, temperatures of the cities, polling results and so on. This information, whether it is numerical or otherwise, is collected with a definite purpose and is called data. Data is used in various aspects of life. So it becomes essential for us to know how to extract meaningful information from such data. It means that suppose there are 100 students in your class and the result has been declared. One student has suppose get 56, another 67, another 77 and so on. Different students, each student has got its own marks. If we write the marks obtained in a single line or many lines, we will not arrive at any conclusion. But if we say that such number of students have got less than 40% marks and such number of students have got more than 70% of marks, this is the presentation of data. That is, we can arrive at some conclusion. If we write simply the information, there is no purpose. We will not arrive at any conclusion. This extraction of meaningful information is studied in a branch of mathematics called statistics. That is the arriving at a decision on the basis of the information collected to arrive at a particular conclusion. It is studied in statistics, and statistics is a branch of mathematics. Statistics deals with collection, organizing, analyzing and interpretation of data. The word statistics had different meanings in different contexts. For example, we take two examples. First is, may I have the latest copy of educational statistics of USA? What it means? Here the word statistics means that the numerical data of a number of educational institutions of USA. That is, the data pertains to how many institutions of USA, and it may also contain the reference to literacy rates of various states, etc. Now we take another example. I like to study statistics because it is used in day-to-day life. In this sentence, the word statistics means the subject or a branch of mathematics which deals with collection, organization, presentation, analysis of data, as well as drawing of meaningful conclusions from the data. In this course, we shall briefly discuss collection of the data and presentation of data. Suppose you are studying in a class and your teacher asks you that you should count the number of fans which are there in the school. What will you do? After the school timings, you may count the same. Or the teacher may ask you, let me know how many girls and boys are in our this class. You may immediately count the same. Further, the expenses of your house are increasing every month, and you will analyze the expenses under different heads. How many expenses I have incurred on electricity, how many expenses I have incurred on, say, food items, and how many on mobile expenses under different heads. So what it will do, it yourself. Next is, when you see the election results on television, all the collection of the data is performed by the employees of the news channel. If you search the Google and find out the literacy rate of USA, it is 88%. Have you counted the literacy rate? No. This work has been done by some other persons or other organizations, and they have published the same in some books, magazines, or I can get the same from the digital data which is maintained by the search engines. So what is the purpose of saying all this? We give below the 5 examples of data that you can collect from your day-to-day life. Now these are the 3 examples we have discussed early. That is the number of boys, girls in our class, number of fans in our school, and electricity bill of our house. In all these 3 works, we have collected the data or used our own, we have got ourselves involved in getting the data. So this is the data where we are involved ourselves. This is the primary data where we are ourselves involved in collecting the data. But in the case of election results which were being shown on the television or published in newspapers or other magazines, the work was done by others. The literacy rate figures have been collected and published by others, and we are only using the literacy rates for the purpose of writing some note. So where the work has been done by some other persons, this is the secondary data. Secondary data. We will now read it about the same primary data and secondary data on the next page. Primary data. Primary data refers to the original data that is collected first hand for a specific purpose or research study. When we collect the data in respect of the fans or the number of boys or class, we are obeying the instructions of the teacher. When we are analyzing the different heads of expenses in respect of our house, that is, we are calculating the electricity expenses for the last 2 years, we are doing it to reduce the expenses under different heads. So we have a specific purpose. Primary data is collected through various methods such as surveys, interviews, observations, experiments, or direct measurements. Here we have used direct measurements. The examples of one primary data are 1, 2, 3, which we have discussed earlier. Now, what is secondary data? Secondary data means the data that has already been collected by someone else for a different purpose and is available for use by researchers and individuals. For example, the literacy rate data was collected by some organizations or individuals. They collected the data on the instructions of the government or the owner of the particular institution, so that the same may be published or the necessary action may be taken by the government to improve the literacy rate in the country. We are only utilizing this data, and that data is called secondary data. This data can be sourced from published materials, government reports, surveys conducted by other researchers or organizations, or digital databases such as search engines. Examples of secondary data have already been discussed at point 4 and 5. Now the question is relates to presentation of data. When we collect the data has to be presented in such a form which is meaningful. We had taken the example of our class where 100 students had appeared in the class and they secured different marks. And if we write on a single page all the marks obtained by different students, it means no purpose. However, if we say that such number of students obtained less than 40% marks and such number of students gained more than 70% marks, and compare it with the previous year's figures, we can say that the performance of the school or the class is improving or decreasing. So this is the presentation of data. That is, we can arrive at the particular conclusion. If we simply write the marks obtained by different students, it will not serve any purpose. So after collecting the data has to be presented in such a form which is meaningful, easily understood, and gives its main features at a glance, so that the necessary action can be taken for the purpose for which it was collected. There are various ways of presenting the data. We will understand the presentation of data with the help of tables. Now we will see. We will here consider first example. Consider the marks obtained by 10 students in a class test given below. Here are the 10 students. One student has obtained 55, another 66, another 95, and so on. Different students have obtained different marks. But what does this data show? Does this mean any sense to you? No. This is raw data. We have simply written the information in respect of the marks obtained by different students. From this picture, this data or information, we cannot, it is difficult for us to find out which is the highest marks and which is the lowest marks. But if we rearrange this information in ascending or descending order, we can easily find out that the lowest marks obtained by the student are this, and the highest marks obtained by any student are this one. Let us arrange these marks in the ascending order, in the increasing order. here we have rewritten. After going through the same, we observed that 25 are the lowest marks, and after that comes 36, after that comes 42, and so on in the increasing manner. We have rewritten the data. So now we can easily say that the lowest marks are 25 and the highest marks are 95. Presentation of the marks in this ascending or descending order is useful or easy when we are to present data in respect of only few number of students. But if we are to present data in respect of say 200, 300 students, then this form of presenting the data in ascending or descending order will become quite difficult. Now we will write see what is written. Presentation of data in ascending or descending order can be quite time consuming, particularly when the number of observations in the experiment is large. So what we can do if the number of entries are more? Now we will see another example. What to do? Consider the marks obtained out of 100 marks, that is the maximum marks are 100, and 30 students have of class 9 of a school have obtained the marks. How many marks they have obtained? One student has obtained 10, another 10, 20, 36, 92, and so on. The list goes on. These are the marks obtained by 30 students out of 100 marks. If we simply go through this data, we cannot make anything because the data is lengthy. However, we can do that. We will find out how many students of 10 marks are there. We will find that from this, that this is the single student. In the same way, 20, any other person or student has obtained 20? No. We will write this is the single student. Then we will find out the 30, whether any person has obtained 36, 36, 36, 36, 36. This is the 36, this is the 36, this is the 36. Any other 36? This is the 36. So 3 students have obtained 36. In this way, we will form the table that how much students have obtained the particular number of marks. In this way, we have formed the table that the particular number of students have obtained these marks. So in this way, 50 marks have been obtained by 3 students. We have formed a table. To make the data more easily understandable, the number of students who obtain a certain number of marks have been mentioned. Where we have done this. This is an ungrouped frequency distribution table, because if we make the group say up to 20, 0 to 20, 20 to 40, 40 to 60, it will be like a group. But here we have mentioned only the marks and the number of students who obtained the relevant marks. This is the ungrouped frequency distribution table, or we can say it that it is simply a frequency distribution table, and the table may become very large if the number of students are very large. So if the number of students or the number of entries are say 100 or more, we will make use of grouped frequency distribution table. What is that? Let us consider another example. Let us now consider the following frequency distribution table, which gives the weights of 40 students of a class. That is, there are 40 students in a class and the weights of all the students have been written, and we have grouped the students on the basis of weight. That is, all the students who have the weight between 31 to 35 have been mentioned here. In the same way, all the students who have the weight between 36 to 40 have been clubbed together, and so on. In the same way, from 75 to 71, only one student is there. That is, the number of students who fall in the group of particular weight are grouped together. This is the grouped frequency table, where we have formed the group of weight, and we have mentioned the number of students against that. Presenting data in this form simplifies and condenses data and enables us to observe certain important features at a glance. From this figure, we can easily say that only there are two students who have the weight equal to 66 or more than that, or there are only 11 students who have weight between 31 to 35 kg. We can arrive at some conclusion, but here is again a problem. What is that? Suppose a student comes new admission and he has weight between 35 kg 0.500 gram, and another student comes which has weight between 45 and 46, that is, he has the weight of 45 kg and 500 grams. Now, where will you put? Because there is no group where we can add these two students. Now we will see it in the next example. So now what will happen if two new students of the weights 35.5 kg and 45.5 kg are admitted in the class? So this is the previous scenario which we have discussed. We cannot add student here. First student which is having 35.5, we cannot add student here because there is gap of 1 kg in each class group. In each group there is a difference of 1 kg. So we cannot. So what is this? What we can do? We will see that there is difference of 1 kg in each group. That is 35 to 36, difference of 1. 45 to 46, difference of 1. 40 to 41, difference of 1. 55 to 56, difference of 1. In each group there is a difference of 1. So this is the lower class limit, this is the upper class limit. Difference is 2 in any two class intervals or in any two groups. So what we will do is we will divide the difference, which is 1, by 2, and it comes 0.5 kg. We will add 0.5 kg to the upper class limit and subtract the 0.5 kg from the lower class limit. We will go in doing the same in each group. That is, in case of 31, we will reduce, that is it, which is the lower class limit, we will reduce 0.5 and it will become 30.5, and we will add 0.5 in the upper class limit and it will become 35.5. In the case of this 36, this is the lower class limit, we will reduce or subtract this 36 by 0.5 and it will become 35.5, and we will add 0.5, that is the half kg, to the upper class limit and it will become 40.5. So you can see that now this becomes continuous, and 35.5, which is the upper class limit in this group, becomes the lower class limit in the next class group. So this becomes the continuous weights. There is no gap in between any of the figures. 65.5. Now again next group starts with 65.5. This group ends with 75.5 and the next group starts with 75.5. Now there is an important point which is to be noted. Suppose there is an entry of say for 50.5 kg in the class. Now where will you add 50.5? Because you can add it here, you can add it here also. If you add it at both the sides, the entry will become double. The students will increase by 2, whereas it will be actually increasing by 1. So what to do? By a say convention, the 55.5 will be taken in the on the next group, and not on the upper class limit, but on the where it is written as lower class limit. So if there is a person which has gained, say, entered the class or taken new admission as say 60.5, it will not be entered in this group, it will be taken in this group by convention. So you can here have observed that if we make the class intervals continuous, any student who gets admission in the class and we make the group on the basis of weight, we can make the proper group. In the same way, if any student say obtains 30.7% marks and groups have been made 20 to 30, 30 and 31 to 40, and we have excluded 30 to 31, then we can make this data continuous in the same manner. Now the next, application of statistics. Statistics is used in a variety of fields including business, economics, social science and natural science. How statistics are used in business and economics? Suppose you have been asked to do a research on the particular product, say washing powder. You are an employee of a company which is dealing with washing powder. You will do the market research and will give your report on the basis of facts and figures that this company is selling its products at this price, this company is selling its product at this price, this is the sale of the particular company, and this is the earnings of the particular company, and how the customers behave if the prices are made up or lower. So all this type of research is based on, or you give your report only in the form of statistics or the data, so that your employer can take necessary decision whether to increase the price or what type of or which price should be set for the product which is to be launched in the market. In the same way, forecasting is done in business, that at what price we are likely to gain maximum profits, or at which price we can get maximum demand from the public. Then we do financial analysis, that is how much profits have been earned by the particular company, what is where they are doing expenses. All these are presented in the form of statistics. All the decisions are taken by the organizations as well as the governments on the basis of the statistics. However, some populist measures are also taken by the governments. We will leave that aside. Most of the decisions which are of business nature are taken only on the basis of the hard facts or the statistics. Statistics is also used in opinion polls. When the polls are likely, say in 1 month, the opinion polls start pouring in on the newspapers that the particular political party is likely to win the majority. How they get this? They conduct surveys and present it on the basis of the particular data that the particular organized or particular political party may win. This is only based on the particular data. Population analysis is also based on statistics. and statistics is also used in understanding social phenomena. Healthcare. Statistics also plays a crucial role in medical research, clinical trials, healthcare planning. Sports. Statistics is used to analyze player performance, team strategies, and making informed decisions in sports. If the particular sportsman is not performing well in the matches which he has played, he may be asked to leave the matches, or he may not be nominated for the next match. How it is decided? It is only on the basis of the performance which is in the form of data or statistics. How many matches he has won, in how many matches his performance was not up to the mark. All this information is only in the form of data or statistics. Quality control. If we are selling a particular brand of product and we are daily receiving many complaints regarding its side effects, what we will have to do? We will do quality control. It is only on the basis of the statistics that we have decided to take this step. Statistics is used in manufacturing industries to monitor and improve product quality. These are only a few examples of how statistics is used in different fields. The applications of statistics are wide ranging. That is, we use the data or the statistics in different spheres of life, and the usage of statistics is growing as in many fields decisions are to be taken on the basis of the data which has been placed before them. We would now like to conclude this course. The information, whether numerical or otherwise, which is collected with a definite purpose is called data. Data is used in various aspects of life. The extraction of meaningful information from the data is studied in a branch of mathematics called statistics. Statistics deals with collection, organization, analysis, and presentation of data. Primary data refers to the original data that is collected first hand for a specific purpose or research study. Primary data can be collected through various methods such as surveys, interviews, observations, experiments, direct measurements, etc. On the other hand, secondary data means the data that has already been collected by someone else and where we are not directly involved, and the data has been collected by someone other for a different purpose, and the said data is available for use by individuals and researchers. The secondary data can be sourced or obtained from published materials, which is in the forms of books, magazines, government reports, surveys conducted by other researchers or organizations, or digital databases. After collecting data, we can present data in the form of tables so that the data is easily understood and give its main feature. In our earlier course on statistics, we had discussed that data is of two types: primary data and secondary data. While the primary data is the data which is collected by us, that is, in which we ourselves are involved in collecting the data, that is, the primary data is the original data, and the primary data can be collected by way of surveys, experiments, observations, etc. On the other hand, secondary data is the data which has been collected by others and the same has been published somewhere, and we are making use of that data. Secondary data can be sourced from government records, newspapers, magazines, books, and digital records. The collected data can be presented in various forms, and one of such forms is to present the data by way of tables. And we can present the data in the form of ungrouped or grouped frequency distribution tables. Now, this course is going to be concentrated on frequency distribution tables. In this course, we will practically find out how to construct frequency distribution when the data is given. Now let us read what is written. After going through this course, the students will understand how to form a frequency distribution table where the data in respect of blood groups of many students is given, and how we can say which is the most common and which is the rarest blood group among the students. The students will also learn how to construct a grouped frequency distribution table when the data in respect of few engineers is given who reside at different distances from the place of work. The students will also learn that if the data in respect of humidity of a certain city for a few days is given, then how to construct a grouped frequency distribution table in respect of that data. And when the class size has also been given, we will also learn how to find the range of the data. The students will also learn how to form a grouped frequency distribution table when the data in respect of height of many students is given along with the class intervals, and what conclusion we draw from the table about the height of students. In a nutshell, in this course, we will learn about the how we can practically form the grouped frequency distribution tables when the data has been provided to us. Now the question before us is, the blood group of 30 students of class 8 are recorded as follows: A, B, O, and so on. Represent this data in the form of frequency distribution table. Which is the most common and which is the rarest blood group among these students? Now, in this question, it is given that there are many students in the class and the blood groups of all these students has been recorded. Now we have been asked to form a frequency distribution table. Frequency distribution table means how many students have the particular type of blood group. That is, in respect of each blood group, we are to count the number of students and to represent the same in the form of a table. This is the question. We are to do this. Now, we will solve this question. Answer. We will first write. Now here we have to form the frequency distribution table. Now we will discuss here, right, what is the meaning of frequency. Frequency is the number of students with the same blood group. That is we will here find out how many students have A blood group, how many students have B blood group. We will form the same in the form of a table. Now, these are the blood groups A, B, O, and AB. These are the 4 blood groups. So we will here form the table. The title will be blood group, then will be tally. That is the number of times a blood group is found in the students. Now here is the number of students. It is also known as frequency. This will be the columns of the table. Now how many blood groups are there? There are A, B, O, and AB. And AB. This is the table which we have formed, and now one of the ways is while counting the students, we can verbally count that this is the first student having A blood group, this is the second, this is third, this is fourth, this is five, this is six, this is seven, and so on. When we are counting the same verbally, it may happen that there may be some disturbance from our classmate, from the colleague, other student which is sitting beside us in the examination, or the teacher who is in the examination hall may ask us to sign the attendance sheet, or some other form of disturbance may be there. And in the meanwhile, we will forget how many times we have calculated, or the number of times particular students having the same blood group. So we should not verbally count, because it will may result into wrong counting, or we will forget how many times we have remembered, or ultimately it will result into wastage of time. So we should count the students manually by writing the same in the examination hall. Now we will count the number of students having A blood group. While counting, we may cut the particular blood group which we have counted. Now this is A, we may write it this way, 1. Number, then this we have counted, this is another, this is third, this is third, this is fourth, this is fourth, this is 5. Now we, instead of writing 5 next in the form of straight line, we will cut it so that we need not to count the same. It will 1, 2, 3, 4, and this will be the 5. Now this is the next 6th, this is 7th, this is 8th, this is 9th. So how many students have blood group A? This is the 9. Frequency of blood group A is 9. We can also say that the number of students having the blood group A are 9. Now we will count the number of students having blood group B. This is B. 1. Number of students 1. 2. Next this 3. 4. 5. This is 6. So the number of students having B blood group are 6, or we can say that the frequency in respect of blood group B is 6. Next O. O blood group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now what is the balance? It is AB blood group. Let us count the same. 1, 2, and 3. These were blood group O. Number of students were 5, 5, 10 plus 2, 12. Now here these are only 3. So now, so far we have built frequency distribution table in respect of 30 students which were having different blood groups. We have formed this frequency distribution table. That is the number of students having a particular blood group. Now what is the another question which is written here? Which is the most common blood group? Most common blood group means when the persons or the students having the number of students having the particular blood group, maximum number of students. The maximum number of students have been found in the case of O. This is the maximum numbers. This is the minimum or rarest blood group. This is the minimum number. So first we will count, right, which is the most common blood group. Most common blood group is equal to blood group with highest frequency. This is the frequency, highest frequency. Or we can also say that maximum number of students. Is equal to most common blood group is O. Maximum number of students are present in respect of blood group where the blood group O has been found are O. This is the most common blood group O. Now the another is rarest blood group. Rarest blood group is where blood group with lowest frequency. Lowest frequency is in respect of AB. Lowest frequency, or we can say that minimum number of students is equal to 3. We have written this here because if we shift to the next slide, we will not be able to see the data which has been formed by us in form of table. So we have written this. When you are writing in the exam, you are to write this below the table. So most common blood group is O and the rarest blood group is AB. Here we have to write not the number of students but blood group. Rarest blood group has been found is AB, where the number of students are minimum. We hope you will have understood how this table has been formed. The students were given having the particular blood group. We have to count each student which is having the particular blood group in the form of a table. We are not to count the students verbally. We have to count the students by writing the same in the form of a tally, and then we have to sum up the same, and this will be the frequency, that is the number of students. And when we form the table, we can easily find out which is the most common and which is the rarest blood group. Now the question before us is the distance in kilometer of 40 engineers from their residence to their place of work was found as follows: 5, 3, 10, 20, and so on. Construct a group frequency distribution table with class size 5 for the data given above, taking the first interval of as 0 to 5, 5 not included. What main features do you observe from this tabular representation? What is the question first? This is. Now, the question is that there are 40 engineers in a particular organization, and here the data in respect of the distance which they have to travel while going to office or workplace is mentioned. One engineer is residing at 5 kilometers, another is residing at 3, another is 10, 20, and so on. This is the distance which they have to travel while going to workplace each day. And now, on the basis of this distance which has been given, we are to construct a grouped frequency distribution table. That is, we will not take that, we will write that A is covering the distance of 5 kilometer, B is covering the distance of 6, C is covering the distance of 10. No, we will form the grouped frequency distribution table. That is, we will form the group. That is, say from 0 to 5 kilometer, number of engineers are this. The number of number of engineers who have to travel, say 5 to 10 kilometers, the numbers is this. From 10 to 15 kilometers, the number of engineers are this. We will form the grouped frequency distribution table. So now, answer. Now first we will have to form grouped frequency distribution table. We will have to form groups. So first, for forming the group, we will have to find out which is the minimum distance a particular engineer has to travel and the maximum distance which an engineer might have to travel to go to office. So first we see minimum distance. Minimum distance is, first we will see here 3, 3, 3, 3, 3, 3, 3. Anything less than 3, this is 2. Anything less than 2, 2, no. So we see the minimum distance is 2 and maximum distance you might ask why we are mentioning maximum or minimum distance. We are mentioning the same because on the basis of this distance we will form the groups or the intervals. So the maximum distance is, here it is 10, 20, 25, 25, 31, 31. Anything more than that, this is 32. Anything more than 32, no. So the maximum distance is 32. So now we will form the group frequency distribution table where 2 is covered and 32 is also covered. So this is written that class size is 5 and the first class interval is 0 to 5. So we take intervals as 0 to 5, 5 to 10, 10 to 15, and so on, and up to we will take 30 to 35, because we will also have to cover the distance of 32 in the distribution table. So here we form the grouped frequency distribution table. So how we will form? First we will write the distance in kilometers. Now we will also have to count the number of persons or the number of engineers who are traveling the particular distance. So here we will only count tally. So here we will actually mention the total of engineers which have to cover the particular distance. So these are the columns which we have to form. So first interval will be 0 to 5, then 5 to 10, then 10 to 15, 15 to 20, 20 to 25, 25 to 30, and 30 to 35. These will be the groups. We will have to mention at these lines, because if we do not mark these lines, the tally or what we write may merge with each other and we will not be able to arrive at particular conclusion. So here we have formed the intervals, that is the distance which the engineers have to travel. We have mentioned the same in groups, that is all the engineers who have to travel say up to 5 kilometers will be mentioned here, and all the engineers who travel from 5 to 10 kilometers will be mentioned in the next group. So here it will be the tally and this will be the outer forming of the table. Now it is to be remembered that when we are talking about 0 to 5 kilometers, in this particular interval we will mention only those engineers who travel less than 5 kilometers, and all the engineers who travel 5 or less than 10 will be mentioned in this. That is, 5 will not be counted in the first interval, 10 will not be counted in the second, 15 will not be counted in the 13th, and so on. That is, this which is the highest interval in the particular group will not be counted. 5 will not be counted in this, 10, because this is the convention that we will take here up to 5. That is, all the engineers who travel less than 5 will be counted here. 5 and above, but below 10 will be counted here. So this is to be remembered, because this is the convention by following. Because if we take the engineer who travels up to travel say 5 kilometers, we will take this, and we will again take 5 kilometers here again, a particular engineer who travels 5 kilometers, then it will result into duplication. That duplication by way of, say, it is going on, we deal with it in such a way that we take it up to 5. We will not count 5. So now we will say this is the first engineer who travels 5 kilometers. It will be counted here and not here. Now this engineer travels 3 kilometers. It will be counted in this. This is the 10 kilometers. It will be counted here and not here. This is 20. It will be counted in this side. Here, which is the lowest and not the highest. Highest will be not be considered. Here 20 is taken. 25 will be taken in this class interval. 11 will be considered in this. 13 13 will be considered in this. 7 will be considered in this class interval. 12 will be considered in this. 31 will be considered in this. 30 to 35. 19, it will fall in between 15 and 20 class group. 12, 10 is to be counted here and not here, as already told. 12 is to be counted here. 17 is to be counted in this 15 to 20. 18, it will be again mentioned here. 11, it will fall 10 to 15. 32, last group. 17, it will fall 15 to 20. 16, it will fall 15 to 20. 2, it will fall in the first group. 7, it will fall in the second, 5 to 10. 9, it will fall again in the same. 7, it will again fall in the same group. 8, it will again fall in the same group. 5 to 20 class interval. 3, it will be in the first class interval. 5, it will be in the second. 12, it will fall in the 10 to 15 range. 15, it will fall in the 15 to 20 range. 18, it will fall the class interval 15 to 20. 3, this will be in the first 0 to 5. 12, it will fall in 12 to 15 range. 14, it will be in the 10 to 15 class interval. 2, first class interval. 9, it will be in the second class interval, 5 to 10. 6, it will be in the second class interval. 15, it will be in between 15 to 20. Again it is 15. It will be again 15 to 20. 7, 5 to 10. 6, it will be again this. And 12, it will be here. Now we will count. This is 5, this is 11, this is 11, 15 to 20, 5 plus 4, these are 9, 20 to 25, the number of engineers who travel 20 to 25 are 1, the number of persons who travel between 25 to 30 are 1, and the number of engineers who have to travel the distance between 30 to 35 are 2, because we are to count the same. This was 5, this was 5 plus 5 plus 1, 5 plus 5 plus 1, 5 plus 4, 1, 1, and 1 plus 1, 2. So here we count the same, because here it is written as these are the 40 engineers. So now we will here also count, so that we may see that actually we have counted all the engineers. 5 plus 11, 16, 27, 36, 37, 38, 38 plus 2, 40. So we have counted all the engineers. So now what is, again we find that what main features do you observe from this tabular representation? Now we go through this table. What is written here? That the number of engineers who have to travel from 0 to 5 are 5, 5 to 10 are 11, 10 to 15 are also 11. So from this table we find that the maximum number of engineers have to travel the distance up to 15 kilometers. So we observe that most of the engineers have their workplace at the distance of 0 to 15 kilometers. This is the 0, this is the 15, and the number of engineers are 20, 27. So most of the engineers have their workplace at the distance of 0 to 15 kilometers from their houses or from their homes. That is, most of the engineers have to travel in between 0 to 15 kilometers. We also find that these are the minimum figures 1, 1, 2. That is, here there are very few engineers who have to travel the distance in between 20 to 35. So next second point which we find that there are very few engineers whose residence is at the distance of 20 kilometer or more from the workplace. That is, we have observed two things. That is, maximum engineers have to travel only up to 0 to 15 kilometers, and there are only a few engineers who have to travel 20 kilometers or more. Here we have been able to construct a grouped frequency distribution table. We hope you might have understood this question very easily. Thank you. Now the question before us is the relative humidity in percentage of a certain city for a month of 30 days was as follows: 98.1, 98.6, and so on. Construct a grouped frequency distribution table with classes 84 to 86, 86 to 88, and so on. Now what is given? First we understand this question, that the relative humidity of a certain city was recorded for 30 days. On one day it was 98.1, other day it was 98.6, and so on. That is, the different humidity was on different dates. We have to construct a table in which we have to show the number of times the particular humidity was there. We have to form the grouped frequency. That is, we are not to write each entry separately. We have to form a table in groups. That is, from the question we can say that in particular entry we will write all the days in which the relative humidity was in between 84 to 86, and then in another group the number of days the relative humidity was 86 to 88. In this way we have to construct a grouped frequency distribution table. Now firstly, to form the intervals we will have to find out the minimum relative humidity and the maximum relative humidity. So now we see minimum relative humidity is minimum 98.1, 90, 86, anything 86, 86 less than 86, 84.9, anything less than 84.9, no. So the minimum relative humidity is 84.9. Now we will find out the maximum relative humidity. Maximum relative humidity. Now what is the maximum? We will find out. Maximum 98.6, 99.2, anything more than 99.2, 99.2, 99.2, 99.2, 99.2, no. So the maximum relative humidity in the given table is 99.2. So we have so far calculated the minimum relative humidity and maximum relative humidity. We have find out the same. So now we are to form the tables which cover the minimum relative humidity as well as the maximum relative humidity. So we take intervals or form intervals as 84 to 86. It will cover 84.9, 84 to 86, 86 to 88, 88 to 90. That is, we will add 2 each time. 99, 90 to 92 and so on up to the point which covers 99.2. So it will be 98 to 100. So now we will form the table. So what is given to us is relative humidity. Relative humidity in percentage. So now we will have to count the relative humidity. So here we will write tally. Then we will have to sum up the tally. That is the number of days in which the relative humidity was falling in the particular class. So here we will mention number of days, or we can also call it frequency. So now here we will write the class intervals 84 to 86, 86 to 88, 88 to 90, 90 to 92, 92 to 94, 94 to 96, 96 to 98, 98 to 100. Up to 100 we will have to form the table. So here it is the table before you which we are constructing, in which we have taken 3 columns. First is relative humidity, second is tally where we will do counting, and then at the last we will mention total of all the days. So it is 84.86. Here we will do separate so that the entries may not merge with each other. I have not been able to draw the lines in straight line, but when you are appearing in the exam, there may be lines on which you may draw the proper, or because we are not having the proper system on which we can draw the lines. So this is the table before you. Here this is the blank table which we have built. Here it will be total which will be counted here. So now we will find out first how many days the relative humidity was in between 84 to 86. No, we will take from the first entry 98.1. 98.1 falls in this range. Here it 98 to 100. Now the second entry is 98.6. It will also fall here. 99.2. It will also fall here. 90.3. 90.3 will fall 90 to 92. 86.5. 86.5 will fall in between 86 to 88. 95.3. It will fall here 94 to 96. 92.9. It will fall here 92 to 94. 96.3. It will fall here 96 to 98. 94.2. It will fall here 94 to 96. 95.1. It will fall 94 to 96. 89.2. 89.2. 89.2. It will fall 88 to 90. 92.3. 92.3. It will fall in between 92 to 94. 97.1. It will fall 96 to 98. 93.5. It will fall here 92 to 94. 92.7. It will fall 92 to 94. 95.1. 95.1. It will fall 94 to 96. 97.2. 97.2. It will fall in the class range of 96 to 98. Now the next is 93.3. 93.3. It will fall here. We have counted 93.3. 95.2. 95.2. 95.2. Here. 97.3. 97.3. It will fall 96 to 98. 96.2. 96.2. 96.2. It will fall 96 to 98. 92.1. 92.1. 92.1. It will fall here. 84.9. 84.9. It will fall here. 90.2. 90.2. It will fall here. 95.7. 95.7. It will fall here. 94 to 96. 98.3. 98.3. It will fall here. 97.3. 97.3. 97.3. It will fall here. 96.1. 96.1. 96.1. It will fall here. 96 to 98. 92.1. 92.1. It will fall here. 89. 89. 89. It will fall here. So now we will count. Before we proceed further, we may tell you that, well, we are forming the grouped frequency table. We must learn, we must understand that suppose there was an entry of 86. We will count it in this class interval 86.88 and not here, because if we count the entry of 86 here, and it will be again counted in the next class interval 86 to 88. So as a matter of convention, we do not take the entry of 86 in the first group, but in the second group where it is the lowest. That is, we do not count the entry on the higher end. Here in the first class interval, we will take any entry up to 86. That is, any entry which is from 84 to less than 86. In the same way, when we come to the other group, we will count all the entries where the relative humidity is 86 to 88. That is 86 to less than 88 and so on. So now here we will count the relative humidity was in between 84 to 86 only for one day, and then it was 86 to 88 only for one day, 88 to 90 for 2 days, it was 90 to 92 for 2 days, and then between 92 to 94, relative humidity was for 7 days. Then the relative humidity was in between 94 to 96 for 5.5 plus 1, it was for 6 days. Then relative humidity was 96 to 98, between 96 to 98, that is less than 98 but 96 or more than that, but up to 98, that is less than 98, it was 7. Then the relative humidity was between 98 and up to 100, it was for 4 days. Then we will count 1, 1, 2, 6, 13, 19, 26, 4, 30. That is, we have counted the number of days from here to here. It means that we have counted all the entries and no entry has been left out. So far we have constructed the grouped frequency distribution table where the minimum relative humidity was 84.9 and the maximum was 99.2. So now another question which is here is, which is month or season do you think this data is about? Here, from this data, we find out that the relative humidity, we find that relative humidity is very high in the given data. Here what is given in the data, the relative humidity is very high as humidity is absorbed to be high during the rainy season so the data is about rainy season. We may add that the relative humidity at any particular city or in a particular location depends upon the weather of that area. We are here talking only about the, in normal circumstances, if such type of data is given, then from this data we observe that the relative humidity is high, as the relative humidity is high during the rainy season. So this data is about the rainy season. Now the next point is, which is third, what is that? What is the range of this data? To find out the range of the data, we will have to sum up the maximum value of data and minimum value of data, and we will have to range of data, we will have to subtract the minimum value from the maximum value. So first we will write the maximum value of data, and from that maximum value we will subtract the minimum value of data. Suppose the range is say 0 to 5, we will say that 5 minus 0, the range is 5. If we say that the range is 5 to 10, we will reduce 5 from 10 and the range will be 10 minus 5, 5. In the same way, when the range of data is here given, we will first find out which is the minimum range minimum data and what is the maximum value of data. Here the maximum value of data which we had find out was the 99.2. So this is the maximum value of data. And what was the minimum value of data? Minimum value of data was 84.9. So here it will be the range of the data which we will get after deducting 84.9 from 99.2. So it is 14.3 when we subtract 84 point from 99.2. So this is the range of the data in which this data is coming into. By now you have find out that if the relative humidity of many days is given, how to construct grouped frequency distribution table and to which season this particular data belongs, and we can find out the range of data by finding out the maximum value of data and minimum value of data, and then we will deduct the minimum value of data from the maximum value of data and we will arrive at the range of data. Now the question before us is the height of students. 50 students measured to the nearest centimeter have been found to be as follows: 161, 150, 154 and so on. Represent the data given above by a grouped frequency distribution table taking the class intervals as 160 to 165, 165 to 170, etc. Here what is given? Here there are 50 students whose height have been measured, and we are to form a grouped frequency table. That is, we are not to mention that one student is having 150, another is having 160. We are not to mention in this way. That is, we are not to form a very big table. We are to form a grouped frequency table wherein the number of students which fall within the particular range, that is, say, between having the height between 160 to 165 fall, and the another group, the students may fall in the range of 165 to 170 and so on. So here we will first find out that what is the minimum height and what is the maximum height, so that we can form the grouped frequency table accordingly. Here we have been given the class intervals as 160 to 165, but if we start from the table 160 to 165, where the entries which are like that 150 and 154 will go. So first we will find out the minimum height and the maximum height. We see minimum height is equal to, so first we will find out the minimum height: 161, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150, 150. No, there is no entry which is less than 150. So we see that minimum height is 150 centimeter. In the same way, we will have to find out the maximum height. Maximum height is 161, 165, 168, 168, 168, 168, 171, 171, 171, 172, 172, 172, 172, 172, anything more than 172, 172, anything in the data 173, 173, 173, 173. So the maximum height is 173 centimeter. So we will have to form the grouped frequency table which covers the minimum height, that is 150, and the maximum height, that is 173 centimeter. So first what is the data is given? Heights are given. So we will write here height in centimeters. As we will have to count the same, our column will be tally. As we will have to sum up the number of students which are having the particular height falling in the particular range or particular class. So here the another column will be number of students, that is the frequency, the number of students having the particular height which falls in the particular range or class interval. So these are the three columns. First is the height, next is the tally, and then total of number of students. Height will be start from 150. So you can see here that there is the class interval has the difference of 5. So when we start from 150, our its end will end at 155. So here we will form the class interval in the same way. 160, another will be 160 to 165, then 165 to 170. We will have to take this class interval up to that point which covers 173. So when we come up to 170 to 175, it will cover 173. So we have formed the table up to 175. This is the table which we have formed. Here we will write total, as we will have to do totaling at the last of the question. Now we will find out the number of students who fall in the class interval of 150 to 155. We will not start from 155 to 155. We will start from the data which has been given. We will start from 161. We will find out first where it particular entry falls. It falls here. We may here add that when we are finding out which entry falls in the particular class interval, we will have to remember that if say the entry falls, say if a particular height is say 155, we will not count it here. We will count it in the next slide, next column, in the next class interval, because it is by convention that when the part here we will count only on the entries which are 150 to up to 155. That is any entry which falls from 150 to less than 155. In the same way, any entry which is less than 160 will be counted in this. Any entry which is equal to 160 or more than 160 but less than 165 will fall in third class interval. This is by way of convention because it will avoid duplication. We can find out that if we take the entry of 155 in this column and 155 is again mentioned here, so it will result into duplication of the entries. So to avoid that, it is by way of convention that the entry like 160 will fall in where it is the minimum starting point. It will be counted here and not here. So here we will come to the mean 161. 161 will be counted between 160 to 165. We will cut 150. 150 will be here. 154. 154 will be here. 165. 165 will be counted here and not here. It will be counted here because all the entries which are equal to 165 or more than 165 but less than 170 will be counted here. Next is 168. It will be counted here. 161. This one. 154. This. 162. 162. It will be counted here. 150. 150 will be counted here. 151, 151 will be counted here. Next is 162, 162, it will be here. 164, 164, 164, this is here. 171, 171, this is here. 165, 165, 165 will be counted here. 158, 158, 158 here. 154, 154, 154 is here. 156, 156 here. 172, 172 is here. 160, 160, 160 is here. 170, 170, 170, 170 is here. It will be not counted in this class interval, but in this class interval. 153, 153, 153, 159, 159, 161, 161, 170, 170, 170, 170 here. 162, 162, 162, 162 here. 165, 165, 165 here. 166, 166, 166 here. 168, 168, 168, it will be here. 165, 165, 165 here. 164, 164 here. 154, 154, 154 here. 152, 152, it is here. 153, 153, it will be counted here. 156, 156, it will be counted here. 158, 158, it will be counted here. 162, 162, 162, it is here. 160, 160, 160, it is here. 161, 161, it is here. 173, 173, it is here. 166, 166, 166, 161, 161, 161, it is here. 159, 159, 159, it is here. 162, 162, it will be counted here. 167, 167, it will fall in the class interval of 165 to 170. 168, 168, 168, 159, 159, 159, it will fall here. 158, 158, it will count here. 153, it will be counted here. 154, it will be counted here. 159, it will be counted here. So now we find out the number of students who are having the height falling in between 150 to 155. Here it is 5, 5, 10, 2, 12. 5 plus 4, 9. 5 plus 5 plus 4, 14. Next, 165 to 170, 5 plus 5, 10. 170 to 175, these are 5. So now we do total 35, 45, 5, 50. So it shows that we have counted all the entries. So we have so far formed the grouped frequency distribution table. The next point is, what do you conclude about their heights from the table? That is what we observe from this table about the heights of students. From this table, we observe that the number of students who are falling in the range between 150 to maximum students fall in the range of 12, 150 to 155, 15 to 160 and 14. So the maximum students fall in the range of 150 to 165. What is the total? These are 35. Total is total number of students are 50 and about and total 35 students out of 50 are having the height between 150 to 165. That is, we can conclude that 35 is more than 50% of 50, because if we calculate 50% of 50, it is 25. That is more than 25. That is the 50% of more than 50%. That is, we conclude that more than 50% of students are having height from 150 to 165 centimeter. Or in other words, we can also write it as that more than 50% of students are having, we can write it as in this way also, are having height less than 165. You can write in any manner that more than 50% students are having height in between 150 to 165, or we can in other words write it as that more than 50% students are having height less than 165 centimeters. It is up to you. You can opt any for it, any of the answers. After going through this course, the students will understand how to make a grouped frequency distribution table where the data in respect of concentration of sulfur dioxide in air of a certain city for the last 2 days is given along with class intervals. In this course, we will understand with the help of practical questions and answers that how we can form frequency distribution tables when the data has been provided to us in different circumstances. Then the students will learn how to prepare a frequency distribution table in respect of the data of number of heads occurred when many coins were tossed many times simultaneously. The students will learn to form the frequency distribution table when the data in respect of the value of pi up to many decimal places is given. The students will also learn how to form a group frequency distribution table when the data in respect of many students is given who watched TV programs for different hours in the previous week. We hope you will find this course very easy and you will be able to understand the concept of frequency distribution table in a very easy language. The students will also learn to construct a grouped frequency distribution table where the data in respect of lives of few car batteries is given. Now the question before us is, a study was conducted to find out the concentration of sulfur dioxide in air in parts per million of a certain city. The data obtained for 30 days is as follows: 0.03, 0.08 and so on. Make a group frequency distribution table for this data with class intervals as 0.002, 0.04, 0.04 to 0.08 and so on. Now what is the question? The question is this, that a study was conducted to find out the concentration of sulfur dioxide in air in a certain city, and the data of 30 days was collected, and now we have been asked to prepare a grouped frequency distribution table. What it means, that we are to build a table showing the concentration of sulfur dioxide in the air. Now, one option is that we write that on first day it was this, second day it was this, and then the data will become, table will become very long. So here we are to form a grouped frequency distribution table. That is, we will make a group, say up to 0.04, then next up to 0.04. In this way, we are to make small groups, just like 1 to 4, then 4 to 8, then 8 to 12. This one. So why, what is the answer? Now we start. Now in this question it is also written that the class intervals are mentioned. So first of all, we will have to find out that when we are to design the table, up to which point we are to form the table. That is, up to which class interval we are to form the grouped frequency distribution table. So for this purpose, we are to find out what is the minimum value and what is the maximum value in the data. So we will here find out, we see that minimum concentration of sulfur dioxide is equal to minimum concentration. We will find out, here it is written as 0.03. We will find out whether any item is less than 0.03. This is 0.03, 0.02, 0.02, this is 0.01. Anything less than that? No. So we find that the minimum concentration of sulfur dioxide is 0.01. So now we will also find out maximum concentration. Maximum concentration 0.08, more than that 0.09, 0.17, 0.18, 0.20, 0.22, 0.22, not more than that. So maximum concentration is 0.22. So we will have to make the class intervals which cover the maximum concentration up to 0.22. So we will make class intervals as, we first will be, which will be covering 0.01. So we will have to start from 0.00, 0.002, 0.04, 0.042, 0.08, and so on up to the point which covers the 0.22, and that will be 0.22, 0.24, so that this entry of 0.22 is also covered in the frequency table. So now what the data is about? This data is about concentration of sulfur dioxide. So we will start forming the grouped frequency distribution table. So we will write concentration of sulfur dioxide. So we can write sulfur dioxide as SO2 ppm, parts per million. So now we will also have to count this data, that is what the particular entry falls in the particular class interval. So for that purpose we will write tally, and we will have to consolidate all the items which fall in the particular range. So here we will write frequency or number of days for which the concentration of sulfur dioxide was falling in the particular range. So number of days, or we will write it as frequency. So this is the table which we have started forming. It will have 3 columns. So first will be 0.002, 0.04. Next will be from this 0.04 to 0.08. Then it will next will start from 0.08 to 0.12. That is, every class interval will have the gap of 0.04. Next will start from this 0.12 to 0.16. Next will start from 0.16 to 0.20. Next will be 0.20 to 0.24. We will form the table up to 0.24 so that the maximum concentration of sulfur dioxide is covered within this table. So this will be the table. We will also have to make the total for how many days we have counted. So now the first is 0.03. We will find out in which class interval it falls. 0.03 falls in this. We will make the entry of the same. We may add that if a particular item, say it is 0.08, we will not count it in the second class interval. For the we clarified first, make lines we draw so that we may not become confused when we consolidate the data. So now if the entry is 0.08, we will not count it in the second class interval, because as it is the tradition that we do not count the entry here. It will be counted in the next slab. If we count it in the second class interval, then 0.08 is also appearing in the third class interval. So if we count 0.08 here, it will be again counted in the third interval, and it will result into the duplication of data, and our answer will become incorrect. So as a matter of tradition, we count it as in the next slide, or next class interval. We here are to count only that entries which are equal to 0.04 to up to 0.08, that is 0.04 to less than 0.08. So first entry we have counted, next is 0.08. 0.08 we will count at here in this class interval. Next it is again 0.08. It is counted here. 0.09. 0.09 is counted in this. 0.04. 0.04 is not to be counted here, it is to be counted here. 0.17. 0.17 falls here. 0.16. 0.16 is to be counted here and not in this class interval as already told. 0.05. 0.05. This is the 0.05. 0.02 here. 0.06, it will fall here. 0.18, 0.18 will fall here. 0.20. 0.20 will not be counted here, it will be counted here. Because anything which is equal to 0.20 or more than that, but up to 0.24 will fall here. 0.11. 0.08. 0.12. 0.13. 0.22. 0.07. 0.08. 0.01. 0.10. 0.06. 0.09. 0.18. 0.11. 0.07. It will be counted here. 0.05. 0.07. 0.01. It will fall here in the first class interval. Now 0.04. 0.04 will be counted here. So now we will count the number of days which fall in the particular class interval. Now we will take the first 0.00 to 0.04. The number of days are 4. In the next class interval, 5 plus 4, these are 9. In the third class interval, 5 plus 4, this is again 9. In the next 0.12 to 0.16, these are 2. In the next, it is 1, 2, 3, 4. And in the next, it is 2. So now we will count the total number of days so that we may arrive at the conclusion that all the entries, that all the data has been accounted for while we have formatted the table. 28 plus 2, 30. So the data in respect of 30 days is given and all these entries are total as 30. So this is the group frequency distribution table which shows that for how many days the concentration of sulfur dioxide fallen within the particular class interval. So this is the grouped frequency table. Now the next is in this question is for how many days was the concentration of sulfur dioxide more than 0.11 parts per million. So we have to find out for how many days the concentration of sulfur dioxide was more than 0.11. More than 0.11. That is, here all the entries are up to, in this class interval, all the entries are up to 0.11. Less than 12, but up to 0.11. So all the entries or all the data which from here to here, that is from 0.12 to 0.24, all the entries which come, that is 2 plus 4 plus 2, that is the 8 entries, that the data in respect of 8 days falls in this particular range. So we will here write our answer for how many days. So our answer will be number of days in which the concentration of sulfur dioxide was more than 0.11 parts per million is equal to 2 plus 4 plus 2, because all these entries fall in the relevant range. 2 plus 4 plus 2, that is 8 days. This is the answer. We have formed the grouped frequency distribution table and also find out the number of days in which the concentration of sulfur dioxide was falling within the particular range which has been asked for in this question. Now the question before us is, 3 coins were tossed 30 times simultaneously. Each time the number of heads occurring was noted down as follows. The data is given. Prepare a frequency distribution table for the data given above. Though this question appears to be very tough, it is not so. When we will solve the question, you will find out the same. Now, first we understand what the question means. It means that we take 3 coins and we toss it simultaneously 30 times. That is, suppose we take 3 coins and for the first time we toss it simultaneously. All the 3 coins are to be tossed at the same time. And what the result is, we record it as, in the first instance, when the 3 coins were tossed, the result was 0. That is, the number of heads were 0. Now, when the 3 coins were tossed simultaneously for the second time, the result was that the head occurred in one case, and same thing going on. And when the coins were tossed for the third time, the result was that the heads occurred 2 times, and so on. The data has been collected 30 times. And one position for one case may be that we form a table in respect of all the 30 days, and the data will become, or the table will become, very long. But here we will form a frequency distribution table. That is, we will find out for how many days or for how many times the particular entry occurred, for how many days the head was counted as 0, for how many days it was counted at 1, for how many days it was counted as 2, for how many days it was counted as 3. As the number of entries will become very less. So here what is given? Here the number of heads have been given. So here now we will form the frequency distribution table. So the first head, we will form the columns where we will first write the number of heads. We will have to count the number of heads which occur, which we will not count verbally, we will write each time. Next, we will count the frequency, that is the number of times the head was found 0 or 1. So these are the columns of the table. So number of heads are either 0 or 1 or 2 or 3. Number of heads, that is, no head has been found, only head has been found in the first only one time or twice, or in all the 3 cases head has been found as. So this is will be the formation of the frequency distribution table. Now we will also here do total so that we may find out that all the entries have been counted out. So the number of heads, for how many times the number of heads was 0? We will not start from here because if we count from here 0, then we will get come to this. No, we will take each and every entry one by one. So first is 0. It will be counted in first. Number of heads 0. Number of heads 1. This will be come here. 2. It will be counted here. 2. It will be counted here. 1. It will be counted here. 2. It will be counted here. 3. 1. Here we are counting the number of times the number of heads occurred. 3. 0. 1. 3. 1. 1. 2. Again 2. 0. 1. 2. 1. 3. 0. Again 0. You will see that when we are counting for the fifth time a particular entry, we are using this so that we may not have to count each time when the entry is 5. 1. 1. 2. 3. 2. 2. And 0. So here we will count 5 plus 1, 6, 5 plus 5, 10, 5 plus 4, 9, 5. If we have not used this line for the fifth time, we will have to count each and every line which we have drawn, which may result into some confusion. So now we will count the frequency so that we may see that we have accounted for all the data. 16, 25, 5, 30. So we have accounted for all the entries, all the data, that is the number of heads. So we have been able to form the frequency distribution table in respect of the number of heads which occurred when the three coins were tossed 30 times simultaneously. So this is the answer before you. You hope you might have find this answer very easy. Now the question before us is the value of pi up to 50 decimal places is given below. Now the question is make a frequency distribution of the digits from 0 to 9 after the decimal point. That is, we are to take into consideration what is written after this decimal point. That is from this point 1 to next. We will count all these entries. We will not take into consideration this 3. So what is given? These are the digits which has been given to us, and we are to make the frequency distribution. So now what is given to us? These are the digits. So now what we are to do? We are to count the same. That is, we will form a column of tally, and then we will have to find out the frequency, that is the number of times the particular digit has appeared in the digit, appeared in the data. So these will be the columns of our table, frequency distribution table. So what will be the digits? Digits will be this 1, 4, these all. So we will start from 0. 0, 1 is there, 2 is there, whether 3 is there? Yes, 3 is there. 4 is there? Yes, 4 is also there. 5 is there? Yes, 5 is there. 6 is there? Yes, 6 is there. 7, this. 8, this. 9, then no entry is 10. So all the entries are 0 to 9. So here we will write total, and this is the outer view of the table. So now we will draw lines so that there is no confusion at any stage, and we are able to arrive at the correct answer easily. To avoid any confusion, we draw these lines. By drawing these lines, we'll be forming proper cell so that the relevant entry is put into the relevant column and relevant row. So the first is 1, where the entry of 1 comes digits, in digits, it comes here. Then 4, digit 4 falls here. 1, it falls here. 5, here. 9, here. 2, here. 6, 5, 3, 5, 8, 9. What we are doing? We are counting the number of times a particular digit has appeared in the data. 7, 9, 3, 2, 3, 8, 4, 6, 2, 6, 4, 3, 3. When we are counting for the fifth time a particular digit, we will draw line this so that we may not have to count all the numbers again. 8, 3, 2, 7, 9, 5, 0, 2, 8, again 8. This is for the fifth time. So we have drawn line, this line. 4, 1, 9. This is for the fifth time. 7, 1, 6, 9, 3, 9, again 9, 3, 7, 5. This is for the fifth time, so we draw line this. 1, this is for the fifth time. 0. So now we count the frequency of the particular digit, the total of the same. This is 2. Digit 1 appeared 5 times. Digit 2 appeared 5 times. Digit 3 appeared 5 plus 3 8 times. Digit 4 appeared 4 times. Digit 5 appeared 5 times. Digit 6 appeared 4 times. Digit 7 appeared 4 times. Digit 8 appeared 5 times. Digit 9 appeared 8 times. Now we will do total of all the frequencies so that we may find out whether we have accounted for all the digits while making this frequency table. 7, 12, 20, 24, 29, 33, 37, 42 plus 8, 50. So we have now formed the frequency distribution of digits. Now what is the next point in this question? The next point is, what are the most and least frequently occurring digits? That is the digit which appeared most times and which appeared least times. So we come to the table again. So what item has appeared most rarely? That is the minimum times. This is the 2. This is the 0 digit which has appeared only on 2 occasions. And what are those digits which have appeared mostly? 8. This is the maximum. And this digit, that is the digit 9, has also appeared maximum. So what is the question? Most frequently occurring digit. So most frequently occurring digit is 3 and 9. 3 and 9. How many times they have appeared? 8 times each. 3 and 9, 8 times. So now what is the least frequently occurring digit? Least frequently occurring digit. What is the least frequency occurring digit? That is the digit which appeared very less times, and that is the 0 digit which has appeared only 2 times. So this was the question, what are the most and the least frequently occurring digits, and now we have solved it here. Because without seeing this table, we would not have been able to give the answer. While when you are appearing in the exam, you are to write this after the table. Hope we have been able to clarify this question in a very simple manner. Now the question before us is 30 children were asked about the number of hours they watched TV programs in the previous week. The results were found as follows. That is, the 30 children were asked for how many hours they were watching the TV programs in the previous week. And in respect of all the children, the data has been given. That is, one child says that he watched TV program only for 1 hour. Another says I watched TV for 6 hours. Third says for 2 hours, and so on. Now, make a grouped frequency distribution table for this data. That is in respect of this data. That is the number of hours TV programs were watched. We are to make grouped frequency table for this data, taking class width as 5 and one of the class intervals 5 to 10. So, we will form the grouped frequency distribution table. Now, we will have, for building the grouped frequency distribution table, we will have to find out the minimum number of hours the television was watched or the maximum number of hours. Now we will find the minimum number of hours. We find minimum number of hours as 1. Anything less than 1? No. And we find maximum number of hours as 6, 12, anything more than 12, 15, more than that 17. So the maximum numbers of hours are 17. So we will have to form the grouped frequency distribution table which covers the minimum number of hours as well as the high maximum number of hours. So we make frequency distribution table with class intervals as, here it is written as 5 to 10, but we are also to consider the minimum number of hours starting from 1. So we will start from, here the class width is written as 5. So we will start from 0 to 5. That is the difference between the maximum class, this point or this point is 5. Here the difference between any class interval is also 5. So 5 to 10, 10 to 15 and 15 to 20. We will form the frequency distribution table in which the class intervals are these 4. So we will write here the data which has been given to us is in respect of the number of hours. Number of hours TV watched, television watched. We will have to count the same. So we will form the column of tally. So next we will have to sum up the number of children, that is how many children watched the television for the particular class interval. So here it will be number of children, or we can count it as frequency. These are the 3 columns which we have formed in respect of the frequency number of hours TV watched, we have formed the class intervals as 0 to 5. That is for all the children who have watched the television for from 0 to up to 5. That is less than 5, but not 5. Next class interval is 5 to 10. So any child who has watched the television, so say for 5 hours, will fall in the class interval this range 5 to 10, and not in this. If we take the child which has watched television for 5 hours in the first class interval, then it will result into duplication, because 5 is written here and 5 is also written here. But as a matter of convention, we will take the entry of 5 in the second class interval. In the same way, if any child has watched television for 10 hours, it will be taken in this third class interval. Next is 15 to 20. So these are the 4 rows of the number of hours television was watched by the children. So this is the first child who has seen the television for 1 hour. It will fall here. Another has watched for 6 hours. It will be counted here. 2. It will be counted here. 3. It will be counted here. 5 hours. 5 hours will be counted here and not here as a matter of convention. 12. It will be counted here. 5. 8. 4. 8. 8 hours. When we are counting any data for the 5th time, we will use this line so that we need not to count the tally. 10, 3, 4, 12, 2, 8, 15. 15 will be counted here and not here, as already told, as a matter of convention. 1, 17, 6, 3, 2. As this is for the 5th time, we will use this line. 8, 5, 9, 6, 8, 7, 14, and 12. So now we will count the number of entries which fall in the particular class interval. So the number of children who watch television in between 0 to 5 hours, they are 5 plus 5, 10. The number of children who watch television for 5 to 10 hours, that is 5 to less than 10 hours, are 13. 5 plus 5 plus 3. Another are who watched television from 10 to up to 15, that is less than 15, they are 5, and 15 to 20 are 2. We make the total of the same 23, 28 to 30. So the data has been given in respect of 30 children. So from this table, it is clear that we have accounted for all the children while preparing this frequency distribution table. So this is the grouped frequency distribution table which is before you. Now the next part of the question is, how many children have watched television for 15 or more hours a week? 15 or more hours a week. As already told that when we are saying about 15, 15 will not be counted here. As a matter of convention, 15 is counted in the next, where it is the lower class limit. This is the upper class limit. So when we are talking about the particular class limit, we will take it as lower class limit. 15 is the lower class limit here. So all the entries where the television has been watched for 15 hours or more than that, it will be counted here. So the answer for us is 2 children. So we will write that 2 children have watched television for 15 or more hours a week. We hope we have been able to explain you this question regarding the viewing of TV programs by some children in the past week in a very simple language. Now the question before us is, a company manufactures car batteries of a particular type. The lives in years of 40 such batteries were recorded as follows. Construct a group frequency distribution table for this data using class intervals of size 0.5 starting from interval 2.25. So now what is given to us? That a particular company, that there is a company which manufactures the car battery, and he has recorded the data in respect of 40 such batteries for how many years the particular battery performed. So what is the data is about? The data is about the lives in number of years of the batteries. So now we will have to construct a frequency distribution table which is in grouped form. So here we will have to find out the minimum value of the data, that is the minimum value in years for which a particular battery might have performed. So we see that minimum value in years is, minimum value is 2.6, 2.6, 2.6, 2.2. 2.2. Anything less than that, no. No battery has the life less than 2.2. So now we will also find out what is the maximum life of any battery which was recorded. Maximum life is 3.7, anything 4.1, 4.5, 4.6, anything more than that. No, there is no battery which was having life more than 4.6. So we have taken these two entries, that is the minimum value in years and the maximum value which was recorded was 4.6, so that we may make the grouped frequency distribution table keeping in view both these items. That is, both these items, both these data should be covered in the grouped frequency distribution table. What the data is about? This is the data about lives of batteries in years. As we will have to count the number of batteries, we make the column of tally. So as we will have to sum up the same tally, we will write here the number of batteries. So we have formed these three columns. So these are the columns. So now we will form the class intervals starting from 2 to 2.5. 2 to 2.5. Now the class intervals are 0.5. So now the next class interval will start from 2.5 to 3. The next will start from 3 and it will go up to 3.5. Next will be 3.5 to 4.0. And the next will be 4.0 to 4.5. And the next will be 4.5 to 5, as we will have to take into account 4.6. So here we will draw the lines so that there is no confusion at any stage when we count the number of batteries which fall in the particular class interval. So here we have formed the overview of the grouped frequency table. Now we will here count the life of the batteries. Next, first is 2.6. That is the one battery was having the life of 2.6 years. So it will be coming in this class interval. 2.6 will come here. It is to be added that if say one battery is having the life of 3 years, it will fall in the third class interval, that is here, as a matter of convention. If say any battery is having the life of say 4 years, it will not be counted here. It will be counted in this class interval 4 to 4.5 as a matter of convention. Because if we count the life of 4 years here, it will be resulted into duplication because the 4 is appearing 2 times. It has been mentioned 2 times as a matter of continuity. In any particular class range, we will take it as, for example, 2 to 2.5 means anything which is having the life of 2 years, but up to 2.5, that is less than 2.5. In the same way, any battery which is having the life of 2.5 and more than that, but up to 3, but that is less than 3. When the battery life comes 3, it will be counted in the next. So in this way, we have to make the entries. So here the next battery is having the life of 3 years, it will be counted here. Next 3.7, it comes here. 3.2. Once the concept is clear to you, there is no problem for you to make the frequency distribution table. That is where you are to put the relevant data. Next is 2.2, 4.1, 3.5, 4.5. Here we have counted 4.5 here and not here. 3.5, 2.3, 3.2, 3.4. When we are counting the entries, suppose 2 entries are having the same value, we will have, do not cut twice at the same time. We will have to use cutting one entry at a one time to avoid any duplication or confusion. 3.8, 3.2. When we were writing any entry for the fifth time, we will use this line so that we may not have to count the any items again and again. So that series we can save the time while solving the questions. 4.6, 3.7. This is for the fifth time. 2.5, 4.4, 3.4, 3.3, 2.9, 3, 4.3, 2.8, 3.5, 3.2, 3.9, 3.2, 3.2 will fall here and it is for the fifth time. 3.2, 3.1, 3.7, 3.4, 4.6, 3.8, 3.2, 2.6, it is for the fifth time. 3.5, it is again for the fifth time. 4.2, 2.9, and 3.6. So now we will count the number of batteries which are having the life of batteries in the falling in the particular class interval. So now we will count the number of batteries which are having the life in between 2 to 2.5 years. These are 2. Next is the number of batteries which are having life of 2.5 to 3 years are 5 plus 1, 6. Now the next is the number of batteries having life in between 3 to 3.5. These are 5, 5 plus 4. 10 plus 4, 14. Now the next are the batteries which are having life 3.5 to 4 years. These are 5, 5, 5, 10 plus 1, 11. 4.0 to 4.5, these are 4. Next is the number of batteries having life in between 4.5 up to 5 years. These are 1, 2, 3, 3. So now we will count the total number of batteries which we have recorded in this data: 2, 6, 8, 22, 33, 37, and 3, 40. So it means that we have accounted for all the 40 batteries in our record. So we have been able to construct a group frequency table in respect of 40 batteries where they were having the life in years and the data for the same was provided to us. We hope we have been able to clarify this question in a very simple language, though all these questions which pertain to the frequency distribution table take some time in solving the same. You are not to get puzzled or go through hurriedly, because if we go through hurriedly in solving the questions, there may be some confusion or we will have to again attempt to solve the question. because there may be some confusion or some error while solving the questions. So we will have to solve these types of questions very patiently. Thanks for watching. If you like our course, please spare some time to give star rating to our course.